Good morning, students. So today we are going to start with ethers, and we'll discuss only two topics today about ethers, not esters. It's called ethers. They're used as a very good solvent. We'll study about their nomenclature and about their structure. Time permitting, we'll talk about their physical properties also. So three topics I think we can take up today in a short video. And as I've heard, there's quite a rumor that school may be closed till 15th of May. So we should be studying seriously. It's not decided. Let's see what comes our way. So let's start with ethers. So we are starting with ethers. The general formula is R O R. What does R stands for? Alkyl group, like methyl, ethyl, and all that. First of all, let us see the structure of ether. Ether has an angular shape. On oxygen, there are two lone pairs, just like water. These are the lone pair of electrons. Oxygen over here has a hybridization of sp3. Now, if you see the first ether, simplest ether, we have dimethyl ether, 2-methyl, an ether functional group. Its bond angle, 2 lone pair, 2 bond pair. The bond angle is approximately 111.7 degrees. That's a bond angle. If you compare the structure with water, water also has the angular shape, 2 bond pair, 2 lone pair. But you know, in water the angle is 105 degree. Any guesses? Since water and ether, they both have 2 bond pair, 2 lone pair. Why angle over here is greater than as compared to water? Reason being, these are the bulky groups, the big groups. They repel each other. A lot of steric hindrance. Because of steric hindrance, the angle is greater as compared to water. So basically, ether, they are angular in shape. They have angular shape. Let's see, due to their angular shape, what happens. Due to the angular shape of ether, even if the 2R group in ether is same, the molecule is going to be polar. Let's see. If suppose ether was linear, it would be non-polar. Reason being R group, it pushes the electron like this. R group, it pushes the electron like this, plus I effect. If ether was linear, these two vectors will cancel each other and it would be non-polar. The vectors will cancel. But since ether is not linear, it is angular, you can see it's polar. So suppose somebody asks you, even if the 2R group, alkyl group in ether is same, still they are polar. Reason being, they have an angular shape. Angular shape of ether make them polar, results into its polarity. Let's see how. Now R group, they are going to push electron like this. R group, it is going to push electron like this, and to the dipole, even these lone pairs will contribute. It will be outwards. The contribution of lone pair towards the dipole is outwards. So you can see all the vectors, they are pointing upwards. They will add up, and the molecule of ether is going to be polar. It has a dipole. it has a negative charge over here and the positive charge over here. Why oxygen have a negative charge? Because the electrons are going towards it. There is a lot of high electron density that is depicted by putting a negative charge. So why ethers are polar even if the two R groups are similar? Reason being because of its angular shape. And due to its high polarity, you will find later on, their water solubility in water will be same as isomeric alcohol. Now let me tell you, ether and alcohol are basically functional isomers. Ethers and alcohol, they are example of functional isomers. They are functional isomers. That is, if you have got an alcohol, you can make ether. If you have got an ether, you can make an alcohol. Suppose we have a molecular formula C2H6O. With this formula, you can make ethanol having a functional group OH. Even you can use it to make a simplest ether, dimethyl ether. So alcohol and ethers, they are functional isomer. An example of structural isomerism. So till now we have done that ether and alcohol, they are functional isomers. Ether, what is the shape of the molecule? It's angular, 2 lone pair, 2 bond pair. And because of its angular shape, it has a polarity. And as ethers are polar, they will be as much soluble in water as alcohols are. Remember, alcohols up to 9 carbon, they are soluble in water. Now next, let us discuss the classification of ether, which is very, very simple. We can have two types of ether. We can have a symmetrical ether, and we have got unsymmetrical ether. Let me give one example, and you find out yourself what is symmetry means and what is unsymmetry means. Like this is an example of a symmetrical ether. Any guesses why it is a symmetrical ether? As both the R groups are same. So if the two R groups are similar, they are called symmetrical. Unsymmetrical like CH3 or C2H5. This is an unsymmetrical ether. The R groups are different. So we have got two types of ether, symmetrical and unsymmetrical. Both of them are polar due to their angular shape. And due to the polarity, their water solubility is similar as compared to the isomeric alcohols. Alcohols and ether, they are functional isomer. Now let's discuss the nomenclature of ether. Nomenclature of ether. First of all, I will be discussing the common name. Let's see how do we give common name to the ether. Then we discuss IUPAC name. For common name, the ether have a general formula R, OR. So the common name is alkyl ether. They named as alkyl ether. Obviously in the alphabetical order. As we will see the examples. The first example, we have CH3 or CH3. What will be the common name? This is which alkyl group? Methyl. This is also methyl. So the name will be methyl ether, or we can call it as dimethyl ether. The common name is dimethyl ether. Let us see the second example. Second example is C2H5, ethyl group, and CH3, which is a methyl group. So what will be its common name? It will be called as ethyl methyl ether. It's ethyl methyl ether. Let's see the next member, a symmetrical ether, C2H5 or C2H5. What will be the common name of this ether? ethyl ethyl ether, or we can call it as diethyl ether. Next one, we have, let's say, C2H5 ethyl. We have got propyl C3H7. So what will be the name? Alphabetical order, ethyl. The other group on that side is propyl, alphabetical order, ethyl propyl ether. Let's see a few more common names. I think these are clear. Let's see some more members. Let's see this one, methyl group. On the other side we have got 3 carbon. In common name we know, we count total carbon. Total carbon is 3, it's propyl. But you can see this is which propyl? This group is there. This is called iso group. So isopropyl. So its common name will be methyl, M for monkey. On the other side we have isopropyl ether. Now some people may say that you write isopropyl first because I comes before M, but let me tell you, while we give the common name, we don't consider this word iso. We'll decide from methyl and propyl. So M comes first as compared to P. Its name will be methyl isopropyl ether, the common name. Let's see the other one. This is a tertiary butyl group, basically butyl group, and this is the methyl group. So this is butyl, this is methyl, so we call it as tert butyl. Again, this is not considered for the alphabetical order. B for boy, butyl, and then methyl, tertiary butyl methyl ether. So when we decide alphabetical order, we don't consider this word iso, secondary, tertiary. We decide on the basis of the name of the group, like propyl, methyl, and so on. Let us see some aromatic ether, the one having the benzene ring. Like the simplest member we have is benzene with OCH3. Benzene with OCH3 is commonly called anisole. Okay. So this compound is commonly called as anisole. We can also call it as methyl, phenyl. This is a phenyl group. Methyl phenyl ether. That's a common name. Let us see the next member, benzene with OC2H5. This is commonly called as phenatol. We can also call it as ethyl phenyl ether. So this is as far as the common name goes. The common name was alkyl ether. Now let's see the IUPAC name. How do we give IUPAC name to the ethers? IUPAC name to the ethers. IUPAC name for the ether. For give IUPAC names, we have to select the long chain of carbon atom, which is called parent chain, and it is named as a derivative of the parent chain. We have to select the long chain of carbon atom having maximum number of carbon atom. The OR group is given a prefix alkoxy. Like if it is OCH3, it is called methoxy, OC2H5, it is called ethoxy, and so on and so forth. Let's see the example. Suppose we have to name these two compounds, the IUPAC name. First of all, we'll be selecting the long chain of carbon atom. Chain of carbon atom. Only the carbon atom should be included. Let's name these three ethers. IUPAC name. In this case, long chain of carbon atom is the one with one carbon. This is a long chain with two carbon. This is a long chain with three carbons. This will be called methoxy. This will be again called methoxy. This will be again called methoxy. The IUPAC name of the ether is alkoxy alkene. So this is methoxy. We write methoxy. Long chain has one carbon, so it's called methane. Derivative of methane. This is a derivative of ethane, so this will be called methoxy ethane. That's a derivative of propane, so this is called methoxy propane. Let's say this one, CH3 CH OCH3 CH3, whose common name was methyl isopropyl ether. Select the long chain of carbon atom. This is the long chain of carbon atom. So it's a derivative of propane. 1, 2, 3. Methoxy at the second position. So its name will be 2-methoxy propane. 2-methoxy propane. Let us see the next example. So it's named as a derivative of the long chain. The IUPAC name is alkoxy alkene. The OR group is given a prefix alkoxy. Let us see this member. Let's give IUPAC name of this, whose common name was tertiary butyl methyl ether. Common name of this ether was tertiary butyl methyl ether. Let's select the long chain of carbon atom. This is a long chain of carbon atom with 3 carbon. 1, 2, 3. Methoxy and methyl. Methoxy and methyl. So its name will be 2-methoxy 2-methyl, and the derivative of propane, 2-methoxy 2-methyl propane, commonly called as tertiary butyl methyl ether. Then remember that anisole. Let's write on the IUPAC name of anisole. What was anisole? Benzene with OCH3. So let's write the IUPAC name of anisole. In this case, 6 carbon, derivative of benzene. So it will be called as methoxy benzene. The derivative of the common name anisole. This one, benzene with OC2H5. Remember the common name I just told you, phenol. This will be called ethoxy with the less number of carbon atom, ethoxy. Basically derivative of benzene, commonly called as phenol. So this was regarding the nomenclature of ether. Ether have a general formula ROR. They used as a good solvent to do the chemical reaction because ethers are very, very unreactive. That should be a good thing for you. If they are very, very unreactive, the chemical properties of ether to be studied will be less, since they are very, very less reactive. Now, time permitting, we can even discuss some of the physical properties of ether. Mainly, we are discussing only 2 properties, solubility and boiling point. So, I discussed while I was discussing regarding the polarity of ether. Ether's solubility in water. Ether's solubility in water is comparable to that of alcohol in water. They are also soluble in water, up to 9 carbon atoms. Because ether, they are polar. This is how we can show the dipole. You know why they are polar? Because of their angular shape. And with water, just like alcohol, they can also form intermolecular hydrogen bonding. They can form intermolecular hydrogen bonding. So this is intermolecular hydrogen bonding. So due to the formation of intermolecular hydrogen bonding with water, they are as much soluble in water as alcohol. Their solubility in water is same as that of alcohols. And it happens like in alcohols, with increase in number of carbon atom, the water solubility will decrease. Why with increase in number of carbon atom, the water solubility decreases? Because this part is non-polar, the hydrocarbon part. With increase in number of carbon atom, the hydrocarbon part, R part, the non-polar part increases or dominates. That's why solubility in polar solvents like water will decrease. It happens even in alcohols. With an increase in number of carbon atom, the water solubility decreases because the non-polar part becomes bigger in size. If we talk about the boiling point, ether's boiling point is less than alcohols. Ether boiling point is less than alcohols. Remember, boiling point depends on what? Boiling point depends on intermolecular hydrogen, intermolecular force of attraction. Intermolecular force of attraction. More the intermolecular force, more is the boiling point of the liquid. Alcohols, we have studied beforehand, they have strong intermolecular hydrogen bonding between alcohol molecules, which is very, very strong. So due to the intermolecular hydrogen bonding, alcohol's boiling point is higher than ether, higher than alkyl halides, higher than aldehyde, higher than ketones. If you see ether, in ether, intermolecular hydrogen bonding is not possible. Can you guess why? In ether, between the two ether molecule, why intermolecular hydrogen bonding is not possible? Can you revise the criteria for molecule to form hydrogen bonding? If you remember 11th class, you have done hydrogen bonding can be made only when the compound has elements like fluorine, oxygen, nitrogen in it, and they should be directly attached to hydrogen. They should be hydrogen directly attached to fluorine, oxygen, nitrogen, small and highly electronegative. You can see in ether we have got oxygen, but it's not attached to hydrogen. So it won't be forming intermolecular hydrogen bonding. But it is polar, it has a dipole. So positive and negative they will attract. This type of interaction is called dipole attracting another dipole. Dipole-dipole force of attraction. But definitely that is weaker than hydrogen bonding. So since dipole-dipole attraction is weaker than hydrogen bonding, alcohols have got higher boiling point as compared to their isomeric ethers. I've already told you alcohol and ethers, they are functional isomers. So today we have discussed 3 topics. We discussed what are ethers, what is their structure. We have seen ethers and alcohols, they are functional isomers. We have seen the nomenclature of ethers, and we have also discussed the physical properties of ether. In tomorrow's class, we'll be starting about chemical properties of ether. But don't worry, ether is quite unreactive, so we don't have much of chemical properties to be done. Maybe in another 2 days, we'll wind up ethers also. Thank you. Have a nice day. Take care.